Hello everybody, this is tonight's flipped video starting on page 45 of your workbook, and we're picking up on example number 3. I know at the end of yesterday we said this would be a debrief. I am actually recording this as tonight's flipped homework. To catch up, I noticed when I was walking around and checking last night's homework, many had done the Mr. and Mrs. Smith question, but hadn't had a chance to fill in this box. So I'm going to include it at the start of this video. At the end of yesterday, we said to help define the variables, look for the phrase blank per each or every blank, because you'll label that value y and what comes after per each or every as x. An example of that is people each year. So the key vocab word there is, my highlighter will cooperate, each. So as soon as I saw each, I know that it's y per, or each, x. So people was y and year was x. This numerical value will also represent the slope, so be on the lookout for those words, per, each, and every. Those are the key 3 words. The slope is the rate it will increase or decrease by, our rate of change, and our y-intercept is the initial value. And those would also be 2 very good vocab words for us to highlight so they stand out in our notes. Let's pick up with this skill, this brand new skill in number 3. And it may not be brand new because some of us maybe did it last year, but it is brand new to our knowledge as part of Algebra 2. It says Solomon charges a $40 flat rate fee. There should be the word fee there. And $25 per hour to repair a leaky pipe. Write a function that represents the total fee charged, y, as a function of hours worked, x. How much does he earn for a 3-hour job? Defining our variables, I noticed when I was reading and I underlined x is number of hours and y is total fee charged. And I also could see that as tying in this idea of looking for per, each, or every, these 3 key words. I see the word per here. And in terms of our labels, y per x. So x is hours, y is money. Now, to be able to write our linear equation, we need to identify 2 super important pieces of information, M and B. $25 per hour is my rate. And then I say, well, what was the initial fee? Is there an initial cost? And I see here, $40 flat rate fee. So this $25 per hour was my slope. $40 flat rate, you're paying that before he even walks in the door. Putting this together to be a linear model, y equals 25x plus 40, and I have my model. We talked today how the pieces that are used to build the model have nothing to do with domain and range. So if you want to lightly cross those out so you don't pull these values by accident, you can. Above domain, I'm going to add the label number of hours. And above range, I'm going to put a $sign because domain is all about time and range is about money. I do have a follow-up question that says, how much does he earn for a 3-hour job? That does not count as a restriction on the domain, because it's not saying as a statement, he will work at most 3 hours. So this is an example of a no given restriction It's a real world restriction. So here, we need to consider, what do we know in general about time? We know that time can't be negative. So the smallest possible number of hours is 0 in the real world, and technically we have no limit on time. Same with money. There cannot be a negative cost to this job. The smallest possible value for money is 0 to infinity. Or I saw some people reason that if I plugged in 0 into my model, that would get me 0 plus 40, which is $40. So for the range 0 to infinity, or I would also accept 40 to infinity, because we could reason that before he's even done any work, you already owe him $40 as an initial fee. Any questions on these two options or which one resonates with you better? You can make a little note on the side and show me tomorrow. We still have this E-part question to answer. How much do you earn for 3 hours? To know how to plug that in, I can look at how I define my variables. X is hours. So I know that that will be an input. We are going to evaluate f of 3 using our model, 25x plus 40. So it's going to be 25 times 3 plus 40. And we can either think mental math here. 25 is like a quarter, 25 cents. If I have 3 quarters, I have 75 cents. Or grab your calculator, and I do 75 plus 40. Oops. And I get 105. So it will cost $105 for that 3-hour job. And let's make this clear. This was a value an X value. F says if Solomon made $240, how many hours did he work? So now we know the money. Money is my Y value. So this is a Y value. So now we're going to plug this in for Y and solve for X. That will look like 240 equals 25x plus 40. Line down the equal sign. And now let's solve this two-step equation. Ask yourself, on this side of the equation where x is there something we could add or subtract? Well, I see a positive 40, so I'm going to choose to subtract 40 from both sides. We get 200 equals 25x. I will divide both sides by 25. And we get 200 divided by 25 is 8. Real world questions have real world answers. So if I'm not sure what the label is, notice you were asked to find how many hours. So 8 hours. That's it. So this is our first example of, in the notes, of building our own model. Taking into consideration we weren't given a restriction, how to say a real world limit on hours and money that can't be negative, 0 to infinity, or if 40 to infinity is what you see, I'll accept that as well by plugging in 0 for x. And then being able to use that function to answer follow-up questions. Let's look at our next real-world scenario about an arrow squid. So this is on page 46. Number 1, an arrow squid has a beak used for eating. Given the length B in millimeters, I'm going to underline that, of an arrow squid's lower beak, you can approximate the squid's mass in grams using this function. Now is where it's going to be really important for us to highlight when we're given a model, because sometimes we will be given one and sometimes we will not be given one. So being able to highlight that model helps us to see, oh, look, it gave it to me. I don't have to do any work for that. B, I know, is the length in millimeters, and M of B is the mass. And I know that because it says this model approximates the squid's mass, and this equals, it's M of B equals. In grams. The B part says, Jasmine is a biologist. She is walking on the beach as part of her research and comes across the beak of an arrow squid. Studying arrow squid is part of her current research. She measures it and finds that the lower beak has a length of 5 millimeters. Approximate the mass of the squid. To answer follow-up questions, when we're given a value, I want you to circle that value and ask yourself, is this a value for B or M of B? So you commit, since we're all doing our notes in pencil, are you going to write B or M of B right here? Well, when I'm seeing this, it says a length of 5 millimeters, and I look, B represents length in millimeters, so I know that this is a value for B. It's an input. So to answer this question, we need to calculate M of 5, which means wherever we see X, or excuse me, in this case, B, we will plug in 5. I'm going to let you finish that one and get an answer that we'll look at tomorrow in class together. Let's compare part C. Part C says, to the nearest tenth of a millimeter, about how long is the lower beak of an arrow squid with a mass of 1,100 grams. So let's circle that. Same question. Is this a value for B or M of B? I see that I've got grams. Grams is M of B. If B versus M of B is not clear, you could add this is a value, an X value. My output function notation, M of B, is a Y value. Since this is a Y value, I'm setting the entire equation equal to it. 1100 equals 236B minus 513, and now I need to solve for X. And again, I'm going to leave that for you to work on. When you're done, make sure you box your final answer. And I'm going to pause the notes there for today, so that if we have a couple extra minutes, it would be great to either go back and catch up on any videos you're missing and let me know how it goes, or if you're all caught up and want to give number 2 a try, that would be fantastic. Have a great day. I will see you tomorrow.